Good afternoon, everyone. I hope you had a nice lunch. And welcome to the session, OpenID Connect in depth. I also hope you already know a thing or two about OpenID, OAuth, using identity server, because that's what we're going to use in this session. But we'll try to tackle a few not so obvious use cases. Anyway, let's start by telling you who I am. I'm Kevin. I'm a freelance architect, and I've been in this sector for about 15 years. I currently mainly focus on APIs and security, which is also why I'm doing a session on security now and one on documenting APIs later on today. On this slide, you can find my GitHub, and you can already find all the code for this session there. But don't run away yet. I still have to explain what it does. On that GitHub, you will also find a few open source projects, and I always need help. So if anyone feels like contributing a bit to one of those projects, just open an issue or send a pull request, and I'll be very happy. Anyway, what are we going to talk about today? We'll start by looking into single sign-on and single sign-out. Now, if you've worked with Identity Server before or with almost any IDP that implements OAuth and OpenID Connect, you know that single sign-on is pretty easy. It's also going to be the shortest and easiest demo for me to give. But single sign-out is quite, or even annoyingly, difficult sometimes. So we'll have a look at what it is, why it's difficult, and how we can use this for both Angular applications and .NET applications, .NET Core applications. After that, we'll look into reference tokens and related to that token revocation. By default, JWTs are used as tokens, so self-contained tokens. They have advantages and they also have disadvantages. Another way of working with tokens is by using reference tokens. They also have advantages and disadvantages. So we'll look into those and we'll see when it's a good idea to use reference tokens and when it's a good idea to use self-contained tokens. And we'll also learn how to revoke those tokens when we can. And lastly, or more or less lastly, we look into API to API communication, but on behalf of the user. So how do you ensure that the identity of the user goes from your identity provider to your client, to the first API, to the second API, and so on? To communicate from one API to another API, you could easily use a client credentials flow, but then you have no notion of the user anymore. In most environments, you do still need a notion of who that user is. And that will mean creating a custom grant. So let's start with the simplest part as far as the demo is concerned, single sign-on. So the general idea is if there are multiple applications and you have one set of credentials, your username and password, you should only have to provide it once. It's a pretty common use case or concern for a lot of companies. Most companies have more than one application running, and an identity provider isn't something you set up for one application. It's always something you set up for a bunch of applications in your company. So if you have that setup, well, you want to ensure that the user only has to provide this username and password once. So how does this work behind the scenes then? You actually get this out of the box. So you don't really have to do anything for it, but it is interesting to know how it works. So imagine you have two applications, application A, application B, and the identity provider, identity server in our case. You want to access application A, but application A doesn't know who you are. So it starts an authorization request to the identity provider, and at level of the identity provider, you provide your credentials. That can be username, password, but it can be anything really. If you implement two-factor authentication, if you want to work with certificates or any other means of authentication, that all happens at level of your identity provider. Once you've done that, the identity provider knows who you are. So at that moment, a cookie is created, the cookie of identity server, stating that identity server knows who you are and that you're logged in there. Once that cookie is there, the identity provider can return whatever you ask. So it can be an identity token, it can be an access token, it can be both, it can be directly via the authorization request, it can be by a more complicated flow. But the main idea is once the identity provider knows who you are, it can do that. So say it returns an identity token to application A. Application A will validate that token. It will take the claims from it, create a claims identity, use that claims identity to create an authentication ticket, which is stored in an application cookie. So from that moment on, application A knows who you are. And then you access application B. Now, single sign-on does not mean that you're magically signed into application B. Application B still doesn't know who you are. So what happens is, if you've configured OpenID at that level, that it will redirect to the identity provider with an authorization request. And because it redirects to that identity provider, your browser will automatically send the identity provider cookie together with that request. So you don't really have to do anything for it. It gets sent automatically. But that means your identity provider does know who you are. So you don't have to log in again. You can simply expect to get an identity token back. And at that time, application B can sign you into application B as well. That's single sign-on. And I'm going to demo that. But before that, let's explain the demos a bit. I have two applications, two client applications. One is an Angular client. It's actually a really simple client. You will immediately see that it has one simple page that will show you the claims of the user. It reads from the identity token and the claims that come from the API. So like that, we can see that the user is still known when talking to the API, something like that. That's the Angular application. It uses OIDC client.js. So if you've worked with OpenID Connect, you probably know about that one. It's by the creators of Identity Server as well. Can be used in any JavaScript application. On the other side, we have an ASP.NET Core application. Simple web client is one, in which I set up OpenID Connect already. So this should be very familiar to most of you, I think. We have a simple OpenID Connect configuration here. The authority is our identity provider, and I created a client with hybrid flow as the supported flow. Then we obviously also have the APIs we're going to talk to. So down here, I don't know if is this big enough for everyone actually? A bit bigger? All right. Maybe that's better. I have something like zoom it so I can zoom in. So we also have two APIs. They also rely on the same identity provider, so they can validate the tokens they get passed in. And the idea is that later on in the session, we're going to have API 1 talk to API 2. And now we have the identity provider itself, this one. It's Identity Server 4 running on ASP.NET Core 3, so all the demos are in Core 3 already. And in this identity provider, I set up two test users, some identity resources, a web client sample for the ASP.NET Core web client using the hybrid flow, and a user agent sample, in this case still using the implicit flow. That one is used for Angular in this case. That's it at the moment. One thing that is a bit of importance maybe is that it's also configured to use a database for operational data. We will need that for the revocation demos. So that means that anything the identity provider needs to correctly keep on working will be stored in a database instead of in memory, which is what you will definitely need once you put this behind the load balancer or something like that. It also allows us to look into that database later on. So this is actually pretty standard setup, I think. So how are we going to demo this? Well, let's say we're going to start the Angular client first. So let's serve this. Oops. I have to type it in the correct window, obviously. And let me start up the IDP as well. Just going to run the IDP for this moment. All right. And now let's go to the Angular application. So HTTPS. There we go. And that obviously redirects to the identity provider at this moment. I can now sign in, and there we go. This is pretty easy, just to show you how the application looks. This takes the information from the token, writes it out. So far for that. So as you could see, I had to effectively redirect to the identity provider and sign in. Now I'm going to start up the web client together with the identity provider and the Angular app, which is still running. So let's set some multiple startup projects. There we go. And that should do it. All right, that's one. This now is the local web client ASP.NET Core running. So let's sign in here. At this moment, I'm being signed into the identity provider, and I'm being signed into the client application. The thing we want to do now is open the Angular application. So let's start a new browser for that. And I don't know if you've seen it, but there was some redirection. I'm automatically signed into this application now without having to provide my credentials. We can also see that because if I look at this correctly, I'll immediately make it a bit bigger, but I have to find the, there we go, a bit lower I think. Yeah, so if you look at this part here, you see that the Angular application, it's a bit higher, I think that'll be better. Here it is. Here's my user agent client. So this is a token that was provided to the user agent from the identity provider. It was valid. And we got that without having to provide input again. So this happened after I started up the identity provider for the second time. So this happened after being signed in once. So that's actually quite easy, right? This was my easiest demo. But now how do you sign out of this? Because there's quite a few things we have to keep in mind now. So let me have a look at this. So what we want to do now, I'm now currently logged into two applications. Once I go to application A and click a logout button, I want to sign out of application A, obviously. I also want to sign out of the identity provider. Because if I don't sign out of the identity provider, and I'll show you this immediately, we will automatically get logged in again once we access the application again. That's not what we want. But when I sign out of the identity provider, I'm not automatically signed out of application B. So application B still knows who I am. So what I'd like to do now is ensure that we automatically get signed out of application B once I sign out of application A, which signs me out of the identity provider. So we sign out once, and we automatically sign out of all the applications that trust the same identity provider. How do you do that then? Well, there's quite a few specifications for that, and they're different for Angular apps versus server-side apps. For server-side apps, there's two types of logouts you can do. Both are supported by Identity Server, by the way. We'll implement one of them. It's a front channel logout and back channel logout. To tell you the difference, front channel versus back channel is API to API or server to server communication. So nothing you do is via redirection with the browser, while front channel communication is always via redirection. Normally, front channel communication is easier to implement as it uses your browser for redirection, which means your browser automatically sends through any state that's required, like cookies or additional stuff via the URI. That's the easiest way to do it, but it's also a bit less reliable because it does rely on the browser redirection, while server-to-server communication is a simple request from one server to another without needing that additional browser in between. But both are implemented more or less the same. But I do have to say that back-channel logouts is, I don't see it implemented a lot in the field, let's say. Mainly because it is harder to implement at level of the client. Because at the client you expect certain state, you need to correctly log yourself out. And to be able to provide that from the identity provider is rarely correctly implemented. But how does that work then, actually? Well, I've got two applications here. And both applications need a sign-out endpoint. So at level of your applications, you need to provide a custom endpoint. And once one application logs out, the identity provider cookie is cleared, and the identity provider will load a page with a bunch of iframes in there. And in those iframes, those sign-out endpoints will be called. And at level of those sign-out endpoints, your application can sign itself out. The reason that this needs to happen like that is that an identity provider cannot clear a cookie of an application. So only the application can clear its own cookie, unless they're in the same domain, let's say, but let's assume they're not. So to log out, I need to clear my application cookie, and the IDP can't do that. So the IDP asks the application to clear it by redirecting to that sign-out endpoint. So that's essentially what happens. And the difference between front channel and back channel is that in case of front channel, the redirection happens in the iframe. In case of back channel, there's still different iframes being opened, but the page that's loaded there is loaded at level of the identity provider, which then sends a server-to-server request to that sign-out endpoint. So it's a little bit different, not that much. Now, for the client, it's a bit different. For an Angular client, let's say, it's a bit different. The specification that exists for that is the OpenID Connect session management spec. This is also front channel, obviously, as your client application runs on your client. All the JavaScript is there. This is still from the previous slide. So we have our application B. We're logged out of the identity provider now. The sign-out endpoint is called. And here we have our application C, the Angular application. It's user agent based in Angular. And the session management spec states that the Angular application is responsible for polling the identity provider at a regular interval. So every few seconds this actually happens. Your application will poll the identity provider and check if there is still a valid session at level of the identity provider. So the identity provider will then respond with, yes, I still know who that user is. Or no, I don't have any notion of user anymore. So you can sign yourself out or do whatever you want to do whenever there is no user anymore at level of the identity provider. So two different approaches to reach the same thing, meaning automatically signing out of your application when one application signs out of itself and the IDP. So let's see how we can do that. Let me think. I'm going to start from, I'm first going to demo something I just told you about. What happens when you don't clear the identity provider cookie. So if you remember from the slide, you have to redirect to the identity provider so the IDP can log itself out. So what happens if you don't do that? And I already have our web client here. So let's click logout. There we go. Specifically, don't redirect to anywhere. Because now I'm simply going to open the application again, and I seem to be logged in again. Even though the logout button, let me show you. This is the code that's executed. So the application cookie is effectively cleared, but because I didn't log out of the identity provider, simply opening the application again, thanks to single sign-out, will ensure that I eventually am logged into myself again. So that's why you also need to sign out of the IDP. Now let's do that. There we go. For that, you simply call into the OIDC scheme, which will automatically redirect via Microsoft's middleware to the identity provider so it can sign itself out. So that's one of the things we want to do. And the second thing we want to do is, well, ensure that our identity provider knows where it can find my sign-out endpoint. So I have to define a sign-out endpoint at level of my application. That sign-out endpoint, well, that's simply it's a logout action. So it's a simple action I create on a controller. I've named it IDP triggered logout. And in that, well, I sign myself out. So it's more or less the same code as you would have when you log out locally. So you sign out of the cookie scheme and you sign out of the OIDC scheme. One difference here is that you first check whether or not the user is authenticated. Because the thing is, the identity provider will automatically trigger all the sign-out endpoints from all the applications you have registered as wanting to act as, wanting to take part in single sign-out. So if you don't include that is authenticated check and don't allow it to be anonymous access, that will fail actually. So it will return a 500 or a 404 or a 403 or a 401, depending on how you implemented it. So this is just to avoid requests failing. So with this, we've created the sign-out endpoint at level of our ASP.NET Core web application. Now we need to register that at level of the IDP because the IDP needs to know it has to call that endpoint. So we open the identity provider. And it's a simple matter of setting the, in this case, front channel logout URI to the URI I just created, or to the action on the controller I just created. From this moment on, identity server will call this endpoint whenever someone logs out of the identity provider. And that someone that logs out, well, we're going to log out of a second app, so we're going to log out of the Angular application. And that should then trigger a logout at level of my web application. I'm going to put a breakpoint there so we can see what happens. So this is what should be triggered, so it can clear its own cookie. All right. Let me start this up. I'm still logged in from my previous session. There we go. Interesting fact, you automatically get, as I said, once you log out, all the registered URIs are triggered. So I log out of this client, I also log out, this endpoint is also called again. But I want to start fresh, so I want to log in. There we go. One application logged in. Now let's open the Angular app in a new browser. Oops. There we go. Automatically signed in. Okay, so now I'm going to click sign out of the Angular application. And I end up in my endpoint at level of my web client. So I simply continue. This is the Angular app. I'm now in my web client. Doesn't look like I'm logged out. I'm still at the same page. But if I click home, for example, I'm actually effectively logged out. So this takes care of logging out, a single logout on that side. On the Angular side, however, we didn't implement it yet. But the nice thing is that OIDC client.js, the library I'm using, actually does that for us. So this makes life a bit easier. Just like you use Microsoft's middleware at level of your ASP.NET Core application, instead of creating all the URIs yourself and instead of writing the validation yourself, you use a library like that at level of the Angular application. So what happens there? Let me log in again first. Let's say Frank password. There we go. And this is, if I refresh this, I should be logged in. This is the Angular app again. There we go. You see that sign out button here? I wrote a bit of code, and I'll immediately show you to get rid of that sign out button. Once this web application, this Angular application gets notified, or due to polling gets notified that there is no session anymore at level of the identity provider. So let's see if I can put these two next to each other. Sample web client. There we go. Oh great, my logout button is hidden. Here we go. I log out there. Obviously that gets triggered. And where is the Angular app? Yeah. Okay, you didn't see it disappear, but it is definitely gone here. If I click home, or no, that's public. If I click home, I'm definitely logged out. Now, how does that work then? Because we didn't really have to write code for it. Well, you don't have to write code for the automatically logging out, let's say. But what you can do is respond to the event. So if you look at OIDC client, so the library, let me make this a bit bigger. Oh, wait. Well, so it's this part here. There, it's a bit better. So if you used OIDC client in the past, you know, to use the user manager in, underneath the covers. So if you handle this event, you can execute whichever code you need or want to execute whenever a logout is triggered from somewhere else. In my case, I simply set the current user to null, which gets rid of the logout, which gets rid of the logout button. But if you prefer, you can use this type of code or handle this event to show a session expired message or something along those lines at level of your Angular client as well. So that's how this is handled. And with that, I can go to the next part, and that is self-contained versus reference tokens. Who's used reference tokens in the past? Few, okay. This is actually the same token you see. So on the left is a self-contained token. On the right is the reference token that refers to that self-contained token. So pretty sure you know what's on the left. You're used to that then. A reference token is nothing more than a reference to the actual contents of what you see on the left. So the name, as the name implies, it refers to the content stored at level of the identity provider. Now, why would you do that? Well, let's have a look at what that self-contained token actually is. This is essentially a protected data structure. It's protected because it's signed. It's a data structure because, well, it's a structure of data containing claims. And thanks to the fact that it's self-contained, this makes it very easy to validate, because everything that's required for validation is in that token. The only thing your API needs to do to validate this is read out a well-known document of your identity provider once, so it knows the public key to validate the signature. Once it knows that, it can simply validate the token whenever it comes in. So there is no more communication with the identity provider once the token reaches your API, which is pretty good for performance. But it also has a slight disadvantage. Depending on how long you make the token valid, the disadvantage becomes larger. Say you have it expire after 1 hour. That's a pretty valid use case. Well, if someone is able to get a hold of your token in that hour, that person has access to your API for 1 full hour. There is no way to revoke that token in between. There is no additional communication with the identity provider to check if that token is revoked or whatever. The token simply gives you access to the API. And that is, okay for some types of applications, but for other types of applications, you really don't want that. You want to be able to revoke access immediately once you find out there's been a breach or if you fire someone and you don't want them to have access to certain APIs anymore with tokens that are stored on their computers. So a reference token allows that. A reference token is an identifier for the actual token. So it references a ground result. It's, correctly executed access token that's returned. It references that stored at the identity provider. So that means that once a reference token comes into your API, the API will communicate with the identity provider to see what is actually in that token. And the identity provider will respond with the JSON from the self-contained token, something like that. And that offers advantages. You can immediately revoke that token at will, whenever you need to. It's a simple, one of the simplest ways to revoke token is simply delete the line out of the database where it's stored. Next time the reference token comes in, talk to the IDP, no ground result, sorry, you're not allowed in. But the disadvantage then is also obvious. It requires communication with the IDP on each request. And, well, that can be quite a big strain on your identity provider. So what is often done in this case is that the ground results are cached in between. So then it becomes a matter of trying to figure out what a good time for the cache is, because, well, if it's cached, there's no more communication with the IDP, and as long as it's in the cache, you will not be able to revoke it. So it becomes a matter of trying to find a good trade-off between too much communication with your identity provider and the need to immediately being able to revoke these tokens. Now let's see how we can do that. So this is actually pretty easy, the first part at least, because Identity Server provides support for reference tokens out of the box. It's a simple matter of configuring your token to be, your access token to be a reference token. So we're at sample web client, the ASP.NET Core client. And all we have to do is set the access token type to reference. And let me run that. All right, let's try another user this time. Claire, password. The password is password, by the way, if you want to run the demo. And here you see the access token definitely being not self-contained. I can't just paste this into jwt.io and get the contents of it. So far, so good. Let's call the API. And I'm pretty sure this should fail. Well, okay, so I don't get a response back. If I look in my code, call API. Let me set a breakpoint here. Response success code is false. Internal server error, it says. Why would that be? I didn't change anything at level of the API, so there's simple access token validation going on there. Well, when you implement something like reference token support, you don't want to allow any API to communicate with the IDP to check that token for being valid or for not having been revoked yet. Because, well, that would mean that as long as the reference, if someone intercepts your reference token, they can just put that in a request to the identity provider and get back the contents of your token. That's not what you want. So there's secrets that have to be used for that, to call into, to let your API verify this with the identity provider. So we have to set up a secret. And that too is quite easy, actually. So there where you define your API resource at level of the identity provider, simply input a secret. So this is the same code as above here, sample API, which has access to a few scopes. But additionally, I add an API secret. And the API then needs to know this secret. So the API is sample API here. And I need to set the API secret here. to allow it to communicate with the identity provider. Now, while I'm here, let me have a look at the IDP database. And that should be Identity Server DB, I think. This makes this a bit more tangible. So here you see the persisted grants. There's still one been running from previously when I was preparing this stuff. But you can see down here a saved reference token. And if you look at the data, you can see that this is actually the data used by, you can already see the claims a bit. This is used by Identity Server to create the actual content of the token from. Okay, let's give this another try. Let me get rid of that. I'll start this up. All right. Let's try calling the API. Is success status code is true this time? And here are my claims from the call to the API. So we now have reference token support. For the Angular app, I'm not going to show that because it's simply a matter of setting the access token type to reference, and the OIDC client.js library takes care of all the rest. So that's pretty easy. Now, I already said that we can revoke tokens simply by deleting a line from the database I've just shown you. That's one way of doing it, but you can also do this programmatically. It's always a good idea to revoke tokens when a user logs out. So they no longer have to be held at the level of the identity provider. It's nice that it gets cleaned up. This is true for self-contained tokens, but also for refresh tokens. Refresh tokens are stored in the same way as these self-contained tokens are stored. So your identity provider needs to know about them, but if they're no longer needed, it's good practice to just clear them. For that, the token revocation endpoint exists. So to call into that, I'm just going to run through the code because it's actually pretty easy here. First thing to do, get the discovery document so your application knows where all the endpoints can be found, including the revocation endpoint. It's always a good idea to use some sort of discovery client for that. This is coming from identity model. I suppose most of you have used that. Identity model? Yeah, okay. These are some extension methods on HTTP client to easily interact with your identity provider. So you get the discovery document so you can read out where the revocation endpoint can be found. And then you send a request. And that request needs to contain the revocation endpoint address, the client and client secret, client ID and secret of which you want to revoke a certain token. And then you also need to pass through the token you want to revoke. So this can be the access token, or it can be a refresh token, or any other custom token actually you want to implement. Same for the refresh token here. So this is pretty easy code. It's not a strict requirement, but it is a good practice just to clean everything up nicely. So I like to do that whenever a user signs out, or whenever a user is signed out because a user signed out of another application. There we go. All right. That's it for reference tokens and token revocation, except for one thing. When should you use reference tokens and when should you use self-contained tokens? Well, a good rule is once a token leaves the company walls, use reference tokens, because it's more dangerous when a self-contained token gets intercepted in a reference token. And what I mean by leaving company walls is when the tokens are exposed via the browser. So for example, if you return an access token via the URI after an authorization request, or even when there's server-to-server communication outside of your company firewalls. So with company can also be your protected cloud environment, by the way. So that's mainly the trade-off, where the trade-off becomes worth it, the trade-off with the additional communication to your IDP, when it becomes worth it. When the token is more susceptible to interception, i.e. when it leaves company walls. All right? Last part, and I kind of like this part, is API to API access on behalf of the user. So imagine this use case. A client application needs to talk to an API. We get an access token. The sub-value is the user identifier, and it has an audience of API 1, which means API 1 will allow access to it. So the client sends the token as a bearer token to the API validates it. The audience is API 1, and the API 1 knows who I am. This is important because you often want to do something in name of the user at level of the API, or depending on who the user is, you might have different rights at the API. And then you need to talk to API 2. But you cannot use this token to access API 2 because API 2 isn't a valid audience or scope that's in that token. So you could solve this by using a client credentials flow. Simple exchange client ID and client secret for an access token. There we are. And that will work. But you have no notion of the user anymore. Client credentials flow is a machine-to-machine flow, so there is no user there. There is no sub-value. So this is a problem. API 2 doesn't know who I am. It's a problem that can easily be solved. Simply ask for an additional scope at level of your client, so API 2 is included in the audiences and scopes list. That same token can be used to access API 1 and API 2. So API 2 now knows who I am again. But this often really isn't what you want. Because if you do it like this, you have, maybe on purpose, maybe not, also given your client direct access to API 2. Your client has the access token with audience API 1 and API 2, so the client can access API 2. And often you want to block that. It really depends on your use case, but I'm quite often in the situation where I do not want my client to directly access an API that's further down the line. So this is a bit of an issue, because what we really want is a client that has access token that gives access to API 1, and API 1 to have an access token in the same name of the token that came in, so with the same sub-value that gives access to API 2. And this is where custom flows come in. So OAuth 2 was actually built with extensibility in mind. The basic flows that are there, let's say OAuth 2 and OpenID Connect, so the basic flows, they're good for basic use cases. But if you need a use case like this, well, you automatically end up in a custom grant or a custom flow. But that doesn't mean we just should start making up flows. That's very rarely a good idea, especially in security, when you deal a lot with security. Creating your own stuff without having 10, 100 people look at it is mostly well, a recipe for disaster. I don't dare to start on that. That's why I really try to give this as a takeaway. Whenever you need something custom, have a look at a standard, because most likely there is already a standard for the stuff you need. And in this case, it's a token exchange standard, which has been around since before OpenID Connect, I even think. The idea behind it is that it describes how to safely exchange tokens for another token, keeping the user that was in the initial token able to flow through to the second token. It can be used for user impersonation. It can be used for user delegation. There are examples on my GitHub of both, by the way, which go a lot deeper than what I can show here. But it's actually really, really cool stuff when you start working with all the typical enterprise scenarios that need this. And for the thing we need now, we can use these impersonation semantics. What you see here is a request from that standard that states how you should do something like this. What you can see is that the grant type is token exchange. The subject token, that's the initial token that gives you access to API 1, is passed through as well. And you state that the subject token type is an access token. The general idea is that we need to take this, we need to validate it, we need to get the subject value out of it, and we need to create a new token that will give me access to API 2. So it's custom, so it also means a little bit of custom development. But just as OAuth 2 was built with extensibility in mind, Identity Server 4 was also built with extensibility in mind. So the general idea when you need stuff like this is read a standard and then find out how to implement it in Identity Server. In this case, what we need is a custom grant validator. So we're going to build a custom grant, which means we need something to validate that grant once it comes in. The grant that comes in, that's the request I've just shown you. So once that comes in, this needs to be checked. And that's why the extension grant validator can be used. It's this interface that we need to implement. There's not that much in that interface. The grant type, which we can get from the slide, and the validate async method, in other words, our actual validation. So how do we do that? Well, grant type is coming from the slide and the standard. Access token type, also a value from the standard and from the slide. Then there's the actual validation, and the context we get passed in here, the extension grant validation context, gives us everything we need to correctly implement this. This contains information on the request that comes in, and it actually contains the full request that comes in. So we have a request, that's the full request we've sent, so we can get access to every part of it. And then we have a result object on that, and that result is what we should set as our new token. So the idea is you get a request in, and we are going to make the result after we validate the request. While it's validation in this case, it's quite easy, because we simply have to implement that standard. We check if the grant type matches the grant type from our slide. So it has to match this. That's the first part. Then we check if there's a subject token passed in. We need an initial token. We check if the subject token type is correctly passed in. So there's our 3 values. And then once we have that, we can validate the token that's passed in. For that, we simply use built-in Identity Server functionality. Identity Server can validate tokens, so we use the validator from Identity Server to validate that token. And once that token is valid, we can create a new one. So what we want to do is get the subject claim from the initial access token. Potentially, and I've written this down to show you what else you could do here. Potentially, you can go and look for claims transformation or check additional rights, like is this user allowed to access API 2? Has he got rights for that? So you can check all of that here. Once that's done, we need to create a new access token, or rather a grant validation result, passing through the subject value we got from the initial token, the claims from the initial token combined with the scopes we asked for, and the type access token. That's it for the custom validator. We need to register it at the level of the identity provider, so we add the extension grant. And then we need to create a client to interact with it. So interacting with it, it's just a matter of creating a client, just like we already created one for the web application and for the user agent-based application. In this case, it is a token exchange client we want to create. And this too is simply a matter of implementing what we saw on the slide already in the standard. So we pass through token exchange as the allowed grant type, and we give it an ID, a secret, and the scopes it has access to. I want it to have access to the second API in this case. That's it at level of the identity provider. We've just created a custom flow. Now we only have to interact with it. So for that, I want my API to call into the second API. That means we have to, let me show you. We now have to create this request. at level of our API. So we're going to create a grant. Again, we get the discovery document to read out the values where the endpoints are. And we create a dictionary of parameters. The subject token type from the slide, the subject token, i.e. the access token we want to pass in, and the scopes. We need access to sample API 2, sample second API, so we ask for that. And then using identity model, the helper classes, I request a new token using that custom grant from the token endpoint. Here's the grant, here are custom parameters, and the ID and the secret we just created at level of the identity provider. The next thing I do is call the second API, and the second API will return the claims at level of that API, which are then added to the claims list and to the client. Okay, let's run this, and then I'm done. I just saw a little plate, the end, which means I need to stop. Well, let me give this a try. So this is our web client we're starting. Let me log in. Doesn't really matter. Reference token, call the API. Success status code is true. So far, so good. Now let's see what we get back. We have the response from the first call. This is the sub value, which is the same sub value as there is at level of our client application. So that's Frank. And these are the claims from the call to the second API, and here's that same sub value again. So we now know how to access, how to let the user identity flow through from API to API by using a custom grant. All right. That's it for this session. You can find the demo code on my GitHub. And if you have any questions, I'd be happy to answer them. No questions? Okay, thanks.
We have 5 minutes for questions.
Oh, yep.
A question regarding Angular approach. So where you have not self-contained but reference token, you said you need a secret to validate it. So how do we securely store that secret on Angular frontend? Or is it a problem or not?
No, you can't securely. So the question is how to securely store those secrets for the reference token. You don't. You can't safely store secrets in Angular applications, but the validation of the reference token or the call to get the correct content from the token happens at level of the API. It doesn't happen at level of the client, so at level of your API you need that secret. And there you can safely store it. So the reference token goes to the Angular app, and the Angular app simply passes it through to the API, and it's at that level of the API that the communication with the identity provider happens. So the API has a secret, but the Angular app doesn't. Okay. Any other questions? Okay, thank you.